So we now get to question 19 in June 2017, paper 2, foundation, and a very visual question. The diagram shows a prism. Now a prism is a shape that has the same cross-sectional area running all the way through. So you can see a trapezium here going all the way through it. Okay, and it says here on the centimetre grid, so again, if you have this printed out, it's a lot easier to do. On the centimetre grid below, draw the front elevation. So this is the front, what would I see? The side elevation, what would I see of the prism? And use a scale of 2 centimetres to 1 metre. It's worth 4 marks. So the first thing I'm going to do is sort out my scales. It says 2 centimetres to 1 metre. So here I've got 2 metres. So it's 2 centimetres to 1 metre. If I had 2 metres here, then I'd double that. So that's going to be 4 centimetres. This one is 1 metre, so it's going to be 1 centimetre I draw. Oh, sorry, no, that's going to be 2. And then this is 0.5. So if 1 metre is 2 centimetres, 0.5 must be 1 centimetre. And this height here is 2 metres. So that must mean it's 4 centimetres. And do I need anything else? Now you might think about needing that, but I don't actually think we need that in the end, and I'll show you why. So I've got to do 2 things, front elevation and side elevation. Let's do the front elevation first. I know I've got to be 4 centimetres up. So, and I'm going to draw it 4 centimetres here, and 4 centimetres across, like that. So that's, I see that line there, that's my base. This little line here is 1 centimetre, and then I connect those. So that is the front elevation, and I'll label it front, like they have. And now the side elevation, a bit more tricky this one actually. If I'm sat here looking that way, I'd see a rectangle, but I'd also see this slant. And there's a temptation to make this 2.5 centimetres. But if you think about it, if you're standing here, looking at it, looking at it that way, you're going to see the top of the height there, which is 2 metres up. So you're not going to see 2.5 metres there. So the total height of this is only going to be 2 metres, 4 centimetres. So that's the height. The width there is 1 metre, sorry. So that's 2 centimetres across. So that's kind of what you're going to see, but I'm going to do one more thing on top of this. That's what you'll see, but you'll also notice, you see this line, you'll see that line, which is 1 centimetre up, and you'll see how that connects with that bit there. Okay, it's like draftsman would have done. And that's how you do it. Okay, looks quite complicated, doesn't it? But there you go. So let's look at question 20. Quite a long question. Let's see if we can get through on this one. And I'll just hopefully do it so you can see it. You should have this paper in front of you anyway, so it's just going through and showing how to do it. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. So I'm just going to draw it like this. Wiggly, wiggly to there, wiggly, wiggly to there. So it's 56 kilometres from Liverpool to Manchester, and then 61 kilometres from Manchester to Sheffield. So I'm just getting a pictorial view of how it works. Ollie's average speed, so his average speed here was 70 kilometres per hour, and it took 75 minutes. So let's just do this. That's our distance, that's our speed, and there's our time. That's our distance, that's our speed, and that's our time. I don't know the speed here, but it says it took 75 minutes. So I've got my setup here, and it then says work out Ollie's average speed from Liverpool to Sheffield. Okay, so his average speed, I have to work out the total distance, which I can do here by adding those two. So I can say, well, it's going to be 56 plus the 61. So I know I've got an average distance of 117 kilometres, but I don't know the time it takes. To work out speed, remember, that triangle, speed is distance over time. So I need to work out what the total time is, and I need to keep it in hours. So I'm going to quickly check that one. There's a fantastic button on your calculator, this button here, that's really powerful. That converts it to hours, minutes and seconds, and I can show you how that works later. But for now, 75 minutes is 1 hour, and then it's 15 minutes. 15 minutes is a quarter of an hour. So in decimal form, I'd write it like that, wouldn't I? That's a quarter. Now what's the time here? Well, distance divided by speed. So I get the distance, 56, and divide by the speed, 70. And that tells me it's 0.8 of an hour. So I know this is 0.8 of an hour because it's all in hours. So I add the total hours together, 0.8 plus the 1.25, and I get 2.05 hours. So my speed is the distance divided by the time. So it's 117 divided by that answer equals S to D. That's how I do that, and I get 57. Does it want it in any? No, so I'm going to say 57.1 because I'm doing one more degree of accuracy than what they gave here. The second part will be in the next video.